Students, good morning. Today's class adiabatic combustion temperature, adiabatic combustion reaction. Adiabatic combustion temperature, adiabatic combustion process. Combustion process in previous class, my first question is what is going to be reaction? Reaction is a process in which reactants are converted into products. It is called as reaction. What is going to be combustion? Again the same principle, reactants are converted into product. Among the reactants, one reactant is a fuel. In combustion process, one of the reactant is a fuel. Another one is oxidizer. That means a fuel is burnt by using a oxygen, molecular oxygen or air. Combustion process. This is called as combustion. A fuel is burnt with the help of oxygen or air. This process is called as combustion process. If the combustion process happens under adiabatic condition, the process becomes adiabatic combustion. Combustion is nothing but it is a reaction. Reaction is nothing but reactants are converted into product. A process in which reactants are converted into products. This is a reaction. Same, combustion is also the same concept of reaction. In reactant side, one of the reactant is a fuel, another one is a oxidizer. That means a fuel is burnt with the help of oxygen or air. It is a burning process. This burning process is called as combustion process. This combustion process happens under adiabatic condition. The process becomes adiabatic combustion. Adiabatic combustion means there is no heat loss. No heat loss or gain. That means during the combustion, fuel burnt by using oxidizer, it releases enormous quantity of heat. The generated heat will not be transmitted to its surrounding because the reaction vessel, process vessel is highly insulated. The released heat is stored as such in the reacting system. Heat loss, cancel this heat loss. There is no heat loss with its surroundings. Released heat is stored as such in the products. It increases the enthalpy of the reacting material or product substance. Consequently, it increases the temperature. The temperature is called as adiabatic combustion temperature. That means it is the highest temperature of a combustion reaction happens under adiabatic condition. The highest temperature of a combustion reaction under adiabatic condition. Adiabatic condition means the released energy is retained or remains with the product stream. The released energy remains with the product stream. Consequently, it increases the enthalpy and temperature of the reacting system. It is the highest temperature of the reacting system or combustion reaction under adiabatic condition. Clear? It is very easy. Right. Adiabatic combustion temperature, adiabatic flame temperature. One more terminology is adiabatic flame temperature. During the combustion process, a visible flame, if it is present, the temperature is called as adiabatic flame temperature. For adiabatic combustion temperature, the example is burning of coal in a combustion chamber. Coal in a combustion chamber. using oxygen or air. Adiabatic flame temperature means burning methane. Burning methane in presence of oxygen or air. It shows visible flame. In such a situation, you have to use the terminology adiabatic flame temperature. Rest of the things are common. Okay, adiabatic combustion temperature. What next? One more terminology, theoretical flame temperature. Theoretical flame temperature. Is there any difference between adiabatic flame temperature and the theoretical flame temperature? The difference is subtle. That means very fine. Very minute difference. நுட்பமான அறிவு. Subtle difference. Minute difference. Okay. Adiabatic flame temperature, adiabatic theoretical flame temperature. Adiabatic flame temperature means assumption number 1, complete combustion. Complete combustion. Second one is it depends on stoichiometric ratio. Stoichiometric ratio. The third one is no dissociation. No dissociation. Fourth one is initial temperature of the reacting material. There are 4 assumptions. Depends on this one. Here, no dissociation means, say for example, combustion of methane using oxygen, it will give carbon dioxide and water. In adiabatic combustion, adiabatic flame temperature, in this concept, carbon dioxide and water are stable component. Carbon dioxide and water are assumed to be stable components. In theoretical flame temperature, combustion of methane with oxygen, the same carbon dioxide and water will produce. In theoretical flame temperature, they are unstable compounds. Carbon dioxide will split into carbon monoxide and oxygen. Water will split into hydrogen and OH group. This dissociation results a decrease in total enthalpy of the reacting system due to its heat capacity. It consumes certain amount of energy. Hence, there will be a loss in total energy. It reduces the temperature. What I am trying to say is, in theoretical flame temperature, definitely there will be a dissociation. Particularly when you cross 1800 degrees Celsius, definitely there will be a dissociation. In such a situation, the total energy is being consumed for dissociated compounds. Certain amount of energy is placed. Hence, total energy gets decreased. Due to decrease in total energy, there will be a decrease in temperature. Hence, what I am trying to say is, theoretical flame temperature is always less than that of the adiabatic flame temperature. Adiabatic flame temperature is greater than that of theoretical flame temperature. Clear? In adiabatic flame temperature, there is no dissociation. The products are stable. In theoretical flame temperature, the products are unstable. There will be formation of new components. Dissociation is present. Okay? Thank you.